All right, so today we're going to go over factoring polynomials with a degree greater than 2. Now, I've done videos on factoring quadratics and some shortcuts there, and I've done a video on synthetic division that if you haven't watched those, you probably want to go back and watch that before you come and watch these. So when we get further along in Algebra 2 and into pre-calc, we're going to have to graph something that's not easily factorable, okay? And what I have for you today is just a bunch of different examples to help show you some tricks and tips to use along the way. So let's take the cubic function x cubed plus 27. And we learn that there's a rule for the sum of cubes. And so the sum of cubes says that if both of these are cube rootable, so x to the third cube rooted is x, and the cube root of 27 is 3. So I know they're both cube rootable. There's a rule that says a plus b, and then a squared minus ab plus b squared. And it's sometimes hard to remember the plus and the minus because they actually change when we do minus 27. So what I remember is when I actually FOIL this entire thing out, when I do the b squared part, I'm going to be left with b cubed as a positive. So that's how I can remember, okay, if that's a positive, then I automatically know that's a negative, all right? So all I do is plug in my numbers. So x plus 3, right, because that's my a, that's my b, and then x squared minus 3x plus 9, okay? And that helps me factor it, at least using this rule. What it doesn't help me do is actually solve it by my factors. Now this will give me x equals negative 3, okay? And that's great. But what about this one right here? If you have to go all the way through and find it, one of the things that you'll find when you actually graph this is most likely, and you can use Desmos calculator to go and check this, but what's going to happen is, because we know a cubic function has potentially 3 zeros, all right? Normally, it's going to do something like this, but in this case, it won't touch the x-axis again. So what's happening is I need a trick for this. Now, some of you will learn how to complete the square, which we'll do a video on. Others, you're going to have to use negative b plus or minus the square root of b squared minus 4ac all over 2a and actually find it. If I were to show you just the discriminant here, what's going to happen is so the discriminant is b squared minus 4ac. So b squared minus 4ac. Well, in this case, b squared is 9 minus 4 times 1 times 9. So there's my a, my b, and my c. I get 9 minus 36 equals negative 27. So that's already telling me that I'm going to have two imaginary roots, which is why you can see that it doesn't actually touch. So there's roots there, but they're imaginary roots, okay? All right, so that's an example of that one. Now, I'm going to leave that up there, and when it comes to x cubed minus 27, what we're looking at there is the difference of cubes. So just to see it side by side, x cubed minus 27 is a minus b, and then a squared plus ab plus b squared. And if you can see, negative b and positive b squared is going to be negative b cubed. So that's how I remember that this is the one I need for this one, okay? So this is x minus 3, x squared plus 3x plus 9. And there I have my factors. And it's the same process as you did before, okay? So again, this is just an overview of different tricks you can use. And I would go back and practice these when it comes to whether something is cube rootable or not. So let's continue on. So now let's say we have 4v cubed minus 5v squared minus 16v plus 20. Okay, so this is going to be an example of factor by grouping. And again, it's a third degree. So I know that it's going to cross potentially 3 times. So I'm hopefully going to have 3 roots. So in this case, what I'm looking for is anything, can I factor out anything that will give me a common term when I'm done? So if I say 2x plus 3x, I'm allowed to say that I know it's 5x, okay? but really it's 2 plus 3x. That's how I actually think of it. Okay, so keep that in mind because it's important right here. So right here, I'm going to say, all right, well, I can pull out from here a v squared. Okay, so when I pull out v squared, I get 4v minus 5. Well, over here, can I somehow make this look like 4v minus 5? I really want to, because then it's just like the 2x plus 3x. Well, I can pull out a negative 4 right here, okay? Might that work? Well, that's going to give me 4v, and then that's going to give me minus 5. So a lot of times when you're factoring by grouping, and in fact, that's the first thing you should look before you try synthetic division, is can I create the same term after I factor? And if I can, now I can group. So now I group the v squared minus 4, okay? And then I leave the 4v minus 5, just like I had my 2x plus my 3x is 2 plus 3x. Okay, so hopefully you can see how those relate. All right, so from here, now, all right, I'm still looking for, remember, for 3 possible roots. Well, can I factor this? Well, hopefully you remember for the difference of perfect squares that this is nothing more than v minus 2 and v plus 2. Okay, so it's the difference of perfect squares, which I would commit those to memory, not just for Algebra 2 class or maybe Algebra 1, but also for SAT, ACT. So now I have my 3. I have v equals 2, negative 2, and when I solve this, I get 5 over 4, okay? And now I have my 3 roots. I can go and graph it, okay? So negative 2, positive 2, and 5 over 4, 1 1/4, so we'll go a little bit past. So here, we have a negative 2, we have a positive 2. This is a positive right here, so it tells me that I go from low to high. So it's going to start down here, it's going to go here, it's going to cross again. Okay, and there's a cubic function. There's 3 roots. All right, so now let's move on to what happens if I can't factor by grouping. All right, so I need a tool, and this is where synthetic division comes in. But first, you might learn this rational root theorem, okay? And, you know, sometimes in math, especially in high school these days, we make up these fancy names, all right? To me, it just makes it a little bit more confusing for students. What I'm really thinking about right here is when I actually solve this out, so I plug in a function or a number into the function, okay? In this case, I'm going to plug in negative 1. If I'm left with a 0 at the end, okay, that means that when x is negative 1, y is 0, okay? So it has no remainder if I'm doing long division or synthetic division, but it also means it's a root because y is 0 and x is a number. In this case, x is negative 1. So negative 1 cubed plus 9 times negative 1 squared plus 22 times negative 1 minus 1. So negative 1 plus 9 minus 22 minus 1. And I can already tell there's no way that'll be 0. So therefore, it's not a root. It has a remainder, so it cannot be one of my roots. Okay. So let's show this one also in synthetic division so that you can actually see how this is going to play out. Okay, because now we're going to solve from here our actual zeros, not in this one, but a different example. All right, so I did a video on this, so go back and watch it, but I bring the 1 down. Negative 1 times 1 is negative 1. That's positive 8, sorry. Negative 1 times positive 8 is negative 8. Positive 14, negative 14, and negative 15. All right, and that's my remainder. So therefore, this will not work. Okay. All right. So hopefully you're still with me. All right. I know it's a lot, but last thing I promise. Okay. So let's take f of x equals x cubed minus 2x squared minus 19x plus 20. And let's say in this case, they told me to check x minus 5. They think that that's a factor. So by synthetic division, if this is the factor, okay, then that really means that x equals 5 is the root. So I plug in 5 here for synthetic division. And I go 1, negative 2, negative 19, and positive 20. Same rules, bring the 1 down automatically. 5 times 1 is 5. Negative 2 plus 5 is 3. 5 times 3 is 15. Negative 19 plus 15 is negative 4. 5 times negative 4 is negative 20. And I get 0. Awesome. That's what I want. Okay? Now, I need to rewrite this. So this is x squared plus 3x minus 4. That is my factored form now, right? So now I'm almost there. So now going back to, again, using the shortcut video that I gave you guys on factoring, this is x, that's a minus. So that has to be a minus, that has to be a plus, okay? And I'm looking for something that multiplies to 4, adds to 3. Hey, what about 4 and 3, okay? I can subtract those and get 3. So I want the positive here and the negative here because I need it to be a positive 3. So now I get x equals 1, x equals negative 4, and x equals 5. I have my 3 roots. I am ready to go and graph this thing. Okay? That's what we're looking for in this case. All right, so let's, one more. So this is assuming they give me one of the factors. They're not always going to do that. All right, so let's go with one where they did not give me a factor. And I'm going to have to do plug and chug. So f of x equals x3 plus 3x squared minus 6x minus 8. Now the ones you're always going to want to check are plus and minus 1 and plus and minus 2. Okay, they're quick, they're fast. So let's check plus 1 and minus 1. So 1, 3, negative 6, negative 8. 1, 3, negative 6, negative 8. Okay, here we go. So 1, 1, that's a 4, that's a 4, that's a negative 2, that's a negative 2, negative 10. Nope, I got a remainder, can't be that. 1, I get negative 1, positive 2, that's a negative 2, that's a negative 8, that's a positive 8, that's a 0. Great, that's exactly what I wanted. Okay. All right, so I know negative 1 is one of my zeros. So because it's that, so x plus 1, we always write the opposite sign as the actual factor. I rewrite this as x squared plus 2x minus 8. All right, I'm going to go ahead and put it with the factor that I already know. All right, same thing. I'm going to use my little cheat sheet shortcut, xx. I'm looking for something that multiplies to 8 and subtracts to 2. How about 4 and 2? Looks like that works. All right, so I know it's a plus and a minus. So the question is, where's the 4 go? Well, because that's a positive, I want the bigger number to be here and the smaller number to be here. So now I just found x equals negative 1. We'll say in order, negative 4, negative 1, and 2. And if I were to graph it, we've got negative 4, negative 1, positive 2. Again, that's a positive, so low to high. And it's probably going to be something like that. Okay? All right, so that's a little bit of everything. Go back and rewatch these if you were stuck. If you're having any specific problems that you want help with, please put comments down there. I want to use this channel to use what people are going through in school as a way to shortcut it. Teaching math, one of the things that I've found, and I came into this after having not been in math for, probably 18 years. And what I noticed was there's all of these amazing ways to do math, but also there's these confusing ways because we try all these different tips and tricks and techniques and standards, I guess is what they call it now. But what happens is we forgot just the basics of how to quickly factor and FOIL, how to use synthetic division, and basically just the very foundational aspects of algebra. And I think it's slowing a lot of the processing down. So I think a lot of it goes back to just remembering the basics and going back and applying them over and over and over. And sometimes you try new things, right? Because I used to use long division a lot. Looked at synthetic division recently, and I was like, wow, that's really fast, right? So a lot of people fight it because they don't understand it. So go back and learn it, and look how fast we did 2 of them. We could have done 2 more just as quick if the positive and negative one didn't work, okay? All right, guys, good luck.